The method of joints is useful for finding all member forces in a truss and is best illustrated with an example. And first you find the reactions and then take an equilibrium of the joints strategically to first identify the zero force members. So the member forces going through joint D are in member DF and BD. And you can verify by horizontal and vertical force equilibrium that these forces are zero. And similarly, if we take equilibrium of joint E, we have the forces in member AE and BE and a vertical force in member EF going through that joint. And by vertical equilibrium of forces, we can observe that the force in member EF is zero. And similarly, if we take an equilibrium of joint C, we have an externally applied load of 1 kilonewton going through that joint, and therefore the force in member CF, I'm going to guess, is pointing to the left to put that force in equilibrium. And we have a force in member AC acting downwards. So therefore a vertical equilibrium of forces tells us that member AC is also a zero force member. And now I'm going to take an equilibrium of joint B. So we have a force of 1.5 kilonewtons going through that joint, which is the reaction. I'm guessing that the force in member BF must act in this direction because it must have a vertical component that puts that reaction in equilibrium. And this angle here is 45 degrees. And therefore, because this force acts to the right, the force in member BE must act to the left to put that force in equilibrium. And now if we take a vertical force equilibrium with the positive forces acting upwards, then we have 1.5 kilonewtons minus FBF sine 45 degrees, and that's equal to 0. And sine 45 is 1 on root 2. So therefore FBF is 1.5 root 2 kilonewtons, which we'll write up here. And because this force is going into the joint B, then this member is in compression. And now if we take a horizontal equilibrium of forces with positive to the right, we have FBF, which is 1.5 root 2, cosine 45 degrees, which is 1 on root 2, minus FBE is equal to 0. And here we have a cancellation, so FBE is 1.5 kilonewtons, which we'll write over here. And because this force is pulling away from joint B, then this member is in tension. And now if we take a horizontal equilibrium of joint E, using a consistent sign convention, then we have FBE, which is 1.5 kilonewtons, minus FAE is 0. So therefore FAE is also 1.5 kilonewtons, which we'll again write over here. And because this member is pulling away from joint E, then this here is a tension member. And if we take a horizontal equilibrium of joint C, using the same sign convention, we have minus FCF plus 1 kilonewton is 0, and therefore FCF is 1 kilonewton. So we'll write that opposite the member. And this force is going into joint C, so this member is in compression. And now if we take an equilibrium of joint A, we have the reaction forces of 1 kilonewton and the vertical reaction of 0.5 kilonewtons. And we also found FAE, which is 1.5 kilonewtons. So therefore the force in member AF must be acting in this direction. To put the 0.5 kilonewton reaction in vertical force equilibrium. And now if we take a vertical force equilibrium of this joint, with upwards being positive, we have minus FAF sine 45 degrees, which gives the vertical component, plus the 0.5 kilonewton reaction is equal to 0. So therefore if you solve for this force, we get FAF is 0.5 root 2 kilonewtons, where sine 45 degrees is 1 on root 2. And we'll write this force over here. And because the force is going into joint A, this member is in compression. So try to visualize how this truss would deform, and the compression and tension will make more sense. Please like, subscribe and comment to help me reach more students.